Yeah.
Good day. My name is Xolile and I'm with my colleague Kapei. Today we'll be presenting to you our MIT808 project titled Empirical Analysis of Appellate Copyright Jurisprudence in South Africa. Presentation will go as follows. We will first give you an overview of the project. Then my colleague Kapei will take you through methodology, modeling, and results. And then I'll close it up with the next steps. The University of Pretoria Law Faculty has identified that there's no empirical investigation of judicial sentiment on copyright issues and questions in South Africa. Yet there are claims that copyright law involves aspects of public policy which are determined by courts. Our objectives in this project is to use data science through the NLP techniques and machine learning to perform sentiment analysis and classification of the judicial rulings in the field of copyright law using the data from Supreme Court of Appeal. We'll have three objectives. One will be to perform sentiment analysis on the different statements. The other two will be to classify the copyright work and copyright issue into the different type of copyright work and issue that are there using the judicial rulings. Kapei will take you through the methodology next.
Thank you. For our data points, we had 36 PDF documents. Each document was containing a copyright appeal court case with the copyright work that was being questioned. After we've collected the data and extracted it, we took our data through our data pre-processing, which involves cleaning our data, removing unnecessary stuff like stop words, full stops, or things that do not really add value to the model. We prepared our data for modeling through tokenization and minimizing the data. Then we also performed an exploratory data analysis just to further understand the data we're dealing with. For our feature engineering, we chose to use Word2Vec. Word2Vec allows us to maintain semantic relationships between words, which would allow us to basically preserve some of the meaning within the text when we convert it to numbers, which would allow us to model. From a modeling perspective, we used H2O to help find an optimal model to solve our different problems. Once we had found our optimal models, we chose to use hyperparameter tuning and cross-validation to further fine-tune our model to work on the given targets. And then after we had built our models, we visualized our results through a dashboard and a presentation. The next slide covers all about the data and other aspects. So on the left side of the presentation, we've got some of the results from our EDA. To the top left is the number of words that appeared the most. At the bottom was a word cloud, which covers the amount of words also that appeared. And as a word appears a lot, it starts to intensify and grow bigger and bigger and bigger. We can see case work and copyright words that appeared frequently. To the top right of the presentation is the different target variables that we were trying to solve for. The bottom right is our dashboard that we had created. Our dashboard has a home page, an EDA section, and a model results tab. In the next section, I'll be touching on our modeling. After we had used H2O to find our ideal classifiers for defense sentiment and copyright work, an XGBO, an extreme gradient boosting model, was the one that was selected. For defense sentiment and copyright work, we achieved an accuracy of 62 and 45 respectively. As you can see, this is a snippet from our dashboard. As we retrain the model, when we get data, we'll see our results improve. For copyright issue, we chose a GBM model or gradient boosting model to solve our targets. The next tab is in more detail, as a more detailed view of the results. So for more detailed view, to the left, we've got a distribution of our target variable. To the right, we've got our confusion matrix covering how our models performed. To the left, we can see we've got a dominant class of infringements for copyright issues. We've also got classes like broadcasting, recording, contract, and royalties, which appeared in a similar percentage. Those three targets were grouped together to reduce modeling noise when we got to that point of modeling. For our defense sentiment, we also have to the left the distribution of the target variable, which is dominated by the reject clause. To the right, we've got a view of the results. For the final work we were trying to predict was our copyright work. To the left, can also see that with this model also we've got a dominant class, which is artistic work. And then to the right is the confusion matrix of the model predictions. We can see that from this that we do have a dominant class and the model was leaning towards a dominant class, but we believe that our pipeline is robust enough to allow us to improve our results through growing our data and having more data points. The final slide will take you through our next steps.
From the work that we have done, our next step is to present the dashboard to the project lead, who will then use it to familiarize himself with what is there and give us feedback on how the project was able to help them. We'll then implement the feedback from the project lead and also request more data to improve the copyright work model performance, or look at other methods such as summarizing the appeal rulings from the documents that we have, as compared to using the whole documentation to train our models. Thank you.
Thank you.